In this video we're going to look at how to graph sine, cosine and tangent functions. So we're going to look at three examples, one of each type. And to start with, we're going to graph y equals sine theta and y equals sinus 3 theta. Now y equals sine theta is a graph you really need to know what it looks like. So the key features occur every 90 degrees or every pi by 2 radians if you're dealing with a radian scale. And the important bit is it begins at 0, 0, and then it has a peak at 90 degrees. It crosses the axis again at 180. It has a trough at 270 degrees, and it crosses the axis again at 0 degrees, and it's going to continue to follow that pattern forever, okay, because it's a wave. So we're going to attempt to sketch this now. Okay, it's not too bad a wave. So that was y equals sine theta. So what does y equals sine 3 theta look like? Well, if you're familiar with transformations of functions, which you should have studied previous to this point, then this is of the f of 3x kind. It just happens that our function this time is sine, and instead of x we've used theta. So what this means is that the x coordinates are going to change 3 times as quickly. So what will this happen to the shape of our graph? Well, I've actually conveniently split this axis so it's in thirds. So sine 3 theta, instead of having a peak at 90, is going to have a peak there at 30. It's going to cross at 60. It's going to have a trough at 90. It's going to cross at 120. It's going to have another peak up here. It's going to cross at 180. And it's going to be there, and there, and there, and there, and there, and there. So let's draw this in. That one was a bit low, should have been there. It's not a great sketch, but it's got all the key features that we need there. It's got the intersections at the right place. It's got the peaks and the troughs in the right place. So you can see it's got the same general pattern, it just appears to be squashed up. So let's consider this graph of cosine. So the basic cosine graph is kind of similar to the sine graph. It just begins in a different position if we take 0 as the beginning. So 0, it crosses at pi by 2, trough at pi, crosses at 3 pi by 2, peak again at 2 pi. So it will look something like that. So what will cosine of pi plus pi by 3 do? Well, this is a translation, and it translates pi by 3 to the right. So I'm just going to mark on where the key points have moved to. And this key point, I'm going to just mark it on here, even though it's out of the range. In fact, I'm going to do the same at the other end, because that will help me scale it properly. Okay. And there we go, we've got a very similar curve, it's just been translated pi by 3 to the left. Now, the final curve we're going to look at is a tan curve, which is quite different. So a tan curve has asymptotes, and it has asymptotes at 90, which we denote with a dashed line, and then again at 270, and then it keeps breaking off. And it looks something like that. So the asymptotes are where there are no values that we can get. So what will y of negative tan theta look like? Well, if it's all negative, then it's going to be a reflection in the x-axis. And it will look something along those lines.